Hello and welcome to Future Cookie. Today we are talking about something that will change the way you think about what life can do. What if the most dangerous object on a battlefield could be detected by something alive? What if the answer was smaller than anything you can see? These are not hypothetical questions. This already happened. Scientists at MIT and the Hebrew University of Jerusalem did something remarkable. They engineered a living bacterium to detect explosives. Not simulate, not approximate, actually sense them. The bacterium lights up like a beacon when it finds a buried landmine. A living organism reprogrammed at the genetic level, doing a job that kills tens of thousands of people every year. Think about that for a moment. Something that evolved over billions of years to survive is now being asked to protect us. Here is how they did it. Landmines are one of the most persistent humanitarian disasters on Earth. Estimates suggest between 60 and 110 million undetonated mines are buried across more than 60 countries right now. Metal detectors miss plastic ones. Trained dogs are accurate but slow. Existing technology fails in certain soil conditions. People die. Children lose limbs. Farmers cannot plant crops on their own land. The researchers asked a different question entirely. What if the ground itself could tell us where the danger is? Explosives like TNT leak trace molecules into surrounding soil over time. Those molecules migrate upward. They exist in concentrations measured in parts per trillion. That is invisible and odorless to humans. But bacteria do not care how small a chemical signal is. They are ancient chemists. Evolution built them to detect molecular signals at concentrations we cannot fathom. The team took a strain of E. coli and rewired its genetic circuitry. They inserted a gene that produces a fluorescent green protein, but only when it encounters TNT-related compounds. Spray a fine mist of these bacteria across a suspected minefield. Shine a low-power laser across the surface at night. Wherever a mine is buried, you see green light glowing up from the soil. In field tests, the system detected buried explosives with an accuracy rate above 90%. That is not a prototype number. That is a number that matters. Now here is where it gets bigger than landmines. This research sits at the intersection of three of the fastest moving fields in science right now: synthetic biology, biosensor engineering, and genetic circuit design. What the MIT team demonstrated is a platform, not just a product. The same logic that makes a bacterium glow green near TNT can be applied to detecting almost any chemical signature. Think about what that means. Environmental toxins in groundwater, early markers of disease in the human body, contraband chemicals moving through supply chains, invasive agricultural pathogens before they spread. The bacterium is not the story. The programmability is the story. We are entering an era where biology is becoming a design material. The genetic code of a living organism is a canvas. Researchers are learning to write instructions on it, the way a software engineer writes code. That shift is one of the most consequential things happening in science right now, and most people have no idea it is underway. Here is what to hold on to as you go about your day. The question is no longer whether we can program life to do useful work. That question has been answered. The question now is how fast we can do it responsibly. How do we govern something this powerful, and who gets access to the tools? Synthetic biology is accelerating alongside AI. Those two curves intersecting is not a distant event. It is already happening in university labs, in biotech startups, in defense research programs around the world. The people building this future are making decisions right now. Decisions about safety, ethics, and access. You do not need a PhD to be part of that conversation. You just need to know what is actually happening. A bacterium that glows in the dark to save a child's life in a minefield is not just a cool scientific trick. It is a window into a world where the boundary between the living and the engineered is being redrawn in real time. And the people who understand that shift will be the ones who help shape what comes next. You just crossed from the world where biology follows nature's rules into the world where we are beginning to write new ones. Thank you for being here. This is Future Cookie.